Welcome to Project Atrium, that is ONF's Open SDN distribution. First, I'd like to take some time to talk about the goals of Project Atrium. The very first goal is that there is actually a lot of open source software that is out there today, but no one's actually taking those open source pieces and putting them together into a vertically integrated stack. Project Atrium's intention is to do exactly that. So we will take a bunch of open source components and use OpenFlow 1.3 and make it work on hardware so that network operators, the end users, can go to one place and download a complete distribution to bring up their networks. We also want to work with multiple hardware vendors and allow the end user to select between different hardware vendors for the use case that they are interested in. And finally, we want to work hand in hand with operators on deployable use cases and give them confidence in SDN-based solutions. So today you get a lot of choices in SDN, and choice is a good thing. It leads to competition, it leads to innovation. But it can be also very daunting for end users to try and take these pieces together and put them. So what Project Atrium says is that we will do all the hard work. We will take these pieces, find the missing pieces, fill out the missing pieces, and create this vertically integrated stack so that you have only one place to go and get an open SDN distribution. So what is Atrium today? Today, it is simply a router. It should look and feel and behave like a regular router that uses eBGP to peer with neighboring routers and switch packets coming in on a VLAN to an outgoing VLAN. But we have done that using this vertically integrated stack that we see over here. You can get bare metal hardware from the Open Compute project, and then use an open API that has been exposed by Broadcom, for example, to go to an OpenFlow agent that will give full access to the tables within the hardware to program from outside using ONOS, an application that we have written on it, and also Quagga that does the peering. So this vertically integrated stack together should be able to give you the look and feel of a regular router. And we do that with not just white box equipment or bare metal hardware, but we have done it now on actually 7 different pieces of hardware. So we actually have built 7 different routers that work in the same vertically integrated stack. The one big challenge that we have encountered when working with multiple different pieces of hardware is that each hardware exposes a different set of tables and a different set of capabilities in the OpenFlow protocol. But we have come up with a means that you don't have to adjust in the application, you don't have to adjust to these different pieces of hardware. So what you can really do is just write the application one time and then write it to an interface, and under that interface, it is implemented in different device drivers for the different pipelines that we are dealing with. So this is a major contribution of Project Atrium, where we have simplified the life of writing of application writers, because they don't have to worry about pipeline, lower level pipeline details. That is handled by the specific driver for that pipeline. But I want to now move on to the demonstration of the work that we have done. We have built a routed network with with traditional routers like Quagga and Viata. But we have also done that with these SDN-based routers. So what you see in this picture is that each router in this picture has its own private AS number, and then we are using eBGP peering between all of these routers, not just the SDN-based routers, but also the traditional ones, to create this routed network, which is advertising hosts from the ends. So, for example, if you look at any one of these routers, for example, the NoviFlow router, it is peering with 3 other SDN routers as well as the Viata router, but it is getting this network from 3 different BGP paths. So in this screen, we can show you that the NoviFlow controller that is running BGP is getting that network, the 200 network that is right at the end over there, from these 3 different BGP paths. One is a 4 router path in the top, another 4 router path in the middle, and then a 3 router path that is in the bottom. And as you can see, BGP has selected the shortest AS path, which is the 3 router path. So we have an ongoing ping that is going from the 1.0 network to the 2.0 network that is selecting this path, which is the 3-router path. So basically what we have here are the BGP consoles for each of these routers, the SDN-based routers, and you can see different BGP level views of the network in each of these SDN-based routers. So we have done a pre-release deployment of this, a test deployment of this in Australia, where we had our routing stack working with another similar SDN routing stack, as well as traditional routers from Cisco and Juniper. And we did this peering across the Pacific from our router stack. The Atrium stack was in Australia, and the other one was in the ESNet. And we exchanged thousands of routes across the Pacific. And we look to continue engaging more operators. For example, Bell Canada has offered that they are willing to try out the Atrium stack in their LAN network, peering with their production network. So what's next? Just quickly wanted to tell you that we will work a little much harder to improve the stability and the quality of the code, and that's coming in the next release. Also, performance testing is very important. And we will also try and introduce new features like IGP. We already have BGP, but we want to add an IGP to it. And also special requests that come from operators. For example, one operator would like to do route filtering in the BGP implementation on the controller before the routes are actually pushed down to the hardware. And finally, we are also looking at expanding this Atrium implementation on other controller platforms like the Open Daylight platform. So we encourage the community to join us. Every open source project lives and dies by the community it creates, and we are really encouraging everyone to join us in this community and add and help us in building this open SDN distribution. To summarize, we have brought together a lot of open source pieces and filled in the gaps in this first Atrium release that is going to come out at the end of this month. We have interoperated and built 7 different OpenFlow based hardware to build these routers. And we are looking to do more and more deployments as we engage with operators. So thank you very much.